Hello, grade 8 students. Today, I will be discussing addition of rational algebraic expression. So for our learning target, I can simplify and add rational algebraic expressions. So as we add rational algebraic expression, it is also the same as adding two fractions. So let us first add rational algebraic expressions with similar denominators. So we're going to simply add the numerators of the two rational algebraic expressions and then copy the same denominator. So example, if we have 3m over 7 plus 4m over 7, as you can see, we have the same denominator. So what are we going to do here is just to simply add the numerator. So we have 3m plus 4m. The answer here is 7m. And then just simply copy the same denominator. So we have 7. And then of course, you need to simplify your answer by canceling the common factor, which is 7. So therefore, as we cancel 7, the final answer would be m. Next, if we have 3x over x plus 1 plus 4x over x plus 1. So again, this one is adding same RAE with the same denominators. So we need to add simply the numerator. So that will be 3x plus 4x. The answer there is 7x. Then just copy the same denominator, which is x plus 1. And as you can see here, this will be your final answer because you cannot anymore factor any polynomials. At the same time, they don't have any common factor. So this will be now your final answer. So next, how about if we have rational algebraic expressions with dissimilar denominators or unlike denominators? So almost the same as adding dissimilar fractions. So we need to get the LCD first of the rational algebraic expression, or the least common denominator. And after that, we have to rewrite the fraction in with similar denominators and using the LCD. And after that, proceed in adding rational algebraic expression with similar denominators. Example, let's add 2 over 3x and 3 over 4x. So the first step here is to get the LCD. Okay, you can use listing method, or you can also use successive division or continuous division as we get the LCD. So the LCD of 3 and 4, it's 12. And for the variable, it will just be x. So therefore, the LCD of 3x and 4x will be 12x. And then after that, we have to rewrite this one using the LCD as our new denominator. So that will be now 12x. So again, write first the LCD, and after that, work now on your numerator. So how are you going to simplify it? So that will be 12x, divide 12x on the first denominator. So 12x divided by 3x, the answer is 4. And then you have to multiply it to the numerator. That's why it is 2 times 4. And then adding, so we have here 12x, again, that's the LCD. Then the same thing that we did in the first fraction. So we need to divide it again by the denominator. So that will be 12x divided by 4x. The answer is 3. And then multiply it to the numerator. So that will be 3 times 3. And then we need to simplify. So 2 times 4, we have 8. And then 3 times 3, we have 9. So as you can see here, we have now a rational algebraic expression with similar denominators. So what are we going to do is to simply add the two numerators. So that will be 8 plus 9, that will be 17. And then just copy the same denominator, which is 12x. And this will be now our final answer. Next, for our fourth example, 3 over x plus 5 plus 2 over x plus 3. So we have unlike denominators again. So to get the LCD, the LCD will just be simply the product of x plus 5 and x plus 3. So it is the same as getting the LCD of two prime numbers. So for example, what is the LCD of 3 and 5? So the LCD will just be 15 by just multiplying 3 and 5. So the same thing here, we have 2 prime factors here, or 2 prime polynomials here. So therefore, we just need to multiply the two expression to get the LCD. Okay? Next, we have to write the two fractions using the same denominator using the LCD, which is x plus 5 and x plus 3. Okay? So proceed. So x plus 5 and x plus 3 divided by x plus 5, the answer will just be x plus 3. And then we have to multiply it to the numerators. That's why it is 3 times x plus 3. Plus, let's proceed to the second fraction. Divide again the LCD by the second denominator. So the answer there will be x plus 5. After that, we have to multiply it to the numerator. And then next, we need to simplify by using distributive method here. So 3 times x will have 3x, and then 3 times 3 will have 9. Plus, so again, just copy the LCD. So 2 times x will have 2x, and then 2 times 5 will have 10. And then after that, simplify by adding the two numerators. So we need to add similar terms or like terms. So that will be 3x plus 2x will have 5x, and then 9 plus 10 will have 19. And then, just copy the same denominator, which is x plus 5 times x plus 3. Other way on writing your final answer is 5x plus 19 over the product of these two binomials, which is x squared plus 8x plus 15. But if you don't want to multiply, that will be okay. Okay, you can have this one as your final answer. Next, for our fifth example, okay, so 2x over the quantity of x plus 1 squared plus 5 over x plus 1. So be careful as we get the LCD here. So the LCD for this example, it's the product of x plus 1 and x plus 1. Or we can also write that one as x plus 1 squared. So as we write this one into fractions with the same denominator, just like this one. And then after that, just divide. So as you can see, this x plus 1 times the quantity of x plus 1 will be the same as this expression. So as we divide two expressions, two same expression, the answer will just be 1. So multiply it by 2x, it will just be the same as 2x. Plus, okay, this LCD divide by x plus 1, the answer will be x plus 1. We need to multiply it by the numerator, which is 5. And then simplify, that will be now, use distributive method. So 5 times x will have 5x, plus 5 times 1 we have 5. And then combine similar terms. 2x plus 5x will have 7x, plus 5 over the same denominator. Or again, you can still simplify this or rewriting it the same as 7x plus 5 over the quantity of x plus 1 squared. But I'll repeat, this can be your final answer. And for the last example, x plus 3 over x squared minus 4 plus 2x over x plus 2. The LCD here, it's x plus 2 times x minus 2 or x squared minus 4. So any of the two you can use in our, as you solve for the sum of these two expressions. So here, I just use x plus 2 times x minus 2 so that it will be easier for you to divide. So as we divide these two expressions, the answer is 1. So just copy the numerator, which is x plus 3. And then next, dividing this expression by x plus 2, the answer will be x minus 2. And then multiply it to the numerator. So simplify, just copy x plus 3 plus distribute 2x. So 2x times x will have 2x squared minus 2x times 2 will have 4x. And then after that, combine similar terms. So as you can see, 2x squared doesn't have any similar term on the other side. So we just need to copy 2x squared. And then combine x and negative 4x. So the answer will be negative 3x. And then just copy 3. Okay? This will be your final answer. But If your numerator is still factorable, then you need to factor it. But 2x squared minus 3x plus 3 is already prime. So, no need for us to write this one in factored form. Or you can also write your answer as 2x squared minus 3x plus 3 all over x squared minus 4. That's it. Thank you so much for watching. If you have question, just message me, Miss Ria, or Sir Alex. Thank you.